All right, in 9.2b, we're continuing on with our significance test claiming a difference between two proportions. Not a whole lot different than yesterday. Same idea that we did before, where the null is going to be the P1 minus P2 equals 0. Okay, that's what we're going to keep it at. You still have the two conditions, random and large counts. We just have to address them about the two samples individually. Both samples have to be random. Both samples have to pass the large counts test. And if you remember, I'm not going to get hung up on the formula, but you do need to know how to use the calculator using that test statistic, finding the test statistic with test number 6 right here, and identifying x1, n1, x2, n2, the correct inequality. All of that will get you the z-score and the p-value to be able to make a conclusion. So really, this video is just another example all the way through the state, plan, do, and conclude process. So here we go. A driving school owner believes that Instructor A is more effective than Instructor B at preparing students to pass the state exam for a driver's license. An incoming class of 100 students is randomly assigned to two groups, each of size 50. That's important. One group is taught by Instructor A, the other is taught by B. At the end of the course, 30 of Instructor A's students and 22 of Instructor B's students pass the state exam. Do these results give convincing evidence at the alpha equals 0.05 level that the Instructor A is more effective? That's going to be key. More effective means they have more people, they will have a greater number passing the test, right? So in the state step, we're going to test at alpha equals 0.05 level. What's our null? Our null is P1 minus P2 is equal to 0. The alternative is that P1 minus P2 is greater than 0. How do I know it's greater than? Because it says greater than here. Now I have to decide which one is P1, which one is P2. Well, they're trying to prove that Instructor A has more students pass. So P1 would be greater, right? The P1 is the proportion of who passed from Instructor A. P2 is the proportion of students who pass from Instructor B. All right, now go to the next step, the plan step. All right, so we need to figure out, okay, P1, P hat 1 is Instructor A. Okay, so that's Instructor A. We said B is going to be P hat 2. Okay, each of them had 50 students. At the end of the course, is 30 of Instructor A's passed and 22 of Instructor B's. So let's think about this. This would be 60%. And on B's, let's see, that's 22 out of 50. Okay, so that's 0.44. All right, so we're going to need those values to do our normal test. But first, let's do random. Okay, we had incoming class of 100 students. So 50 were randomly assigned to Instructor A, 50 randomly assigned to Instructor B. Okay, so for normality, we need to check large counts. So we do A first. So 50 times 0.6 gives me 30. That's greater than or equal to 10. Then I'll do 50 times 1 minus 0.6. That's going to be 20, greater than or equal to 10. So far, so good. Instructor B, I had 50 times 0.44. That would be 22, greater than 10. 50 times 1 minus 0.44 gives me 28, and that's greater than or equal to 10. So I've shown my conditions are met, random and normal, because I've dealt with each sample individually. Now for the do step. Okay, So remember instructor A, so x1 and 1. These are instructor A. She have 30. X2 was 22. N2 was 50. And remember our alternative was a greater than, right? So we're going to use all that information to calculate my z-score. So I go to stat, over to tests, and I want number 6. So let's plug in our values. We have 30 out of 50, 22 out of 50, and it is greater than, so I'm going to leave it at greater than and hit calculate. So my z-score is 1.60, okay? 1.60. So I need to draw my curve. Draw the curve. Here's the center. So 1.6 is over here. So shade it. And the p-value is 0.054. Okay. Now that's going to be helpful on our conclude step. All right. We jump to the conclude. Remember what p was. Let's rewrite p real quick. All right. So connect p-value to alpha. It's greater. So because 0.054 is greater than 0.05, we fail to reject the null. Okay? We do not have convincing evidence that, now, what you're having convincing evidence, I'm going to switch you back real quick to the alternative. Remember what the alternative was? That the difference between instructor A and instructor B is greater than 0. That's what we don't have evidence of. Okay? So be careful here. The difference in the proportion passing students between instructor A and B is greater than 0. Okay, we don't have evidence it's greater than 0. What does that mean in real terms? That means we really don't know if instructor A is better than B. We don't know. But this is the way we have to word it. Remember that the difference in the proportion of all of this business right here is restating your alternative hypothesis. So don't make it anything else, just restate it in words. Okay? So that gets you through a 4-step process using 2 proportions. Hope that makes some sense, and we'll see you in class.